Okay, today let's study 3 topics. The 3 topics are trigonometry, um, reading data, and probability. Well, these 3 topics actually are kind of easy. The question that you can see here are based only on a few principles. Trigonometry questions in the SAT are not that hard. For example, you don't have to deal with very difficult trigonometrical identities. No, the most simple identities we'll see, but nothing very hard. And then reading data is about the ability to interpret charts and tables. And probability is also, a simple type of question based on the concept, basic concept of probability that usually is considered as the way to interpret some tables in the question stems. So let's begin. Here in this part, we'll see first trigonometry. So what is the foundation of trigonometry? Okay, hello there, Luciana. Welcome. Let's begin the class. In trigonometry, well, we basically need to manage the 3 basic trigonometric functions. You have studied trigonometry at school, so a trigonometric function is defined around the value of a certain angle, usually angle measured either in degrees or in radians. But we can always visualize easily the basic values of the 3 functions, that is to say the sine, the cosine, and the tangent, using this triangle. Constructing a triangle, any triangle, based on which one of the angles that is not the right angle is the angle whose trigonometric functions we want to determine. So we can just remember that, for example, in order to determine the sine of this angle, this can be obtained by calculating the ratio of 2 lengths, the opposite side to the angle, that is this one, and the hypotenuse. So dividing the opposite side by the hypotenuse, that yields the ratio that we call the sine of x. And for the cosine of x, you simply can say that the length of the adjacent side divided by the hypotenuse, that yields the cosine. And the tangent is just the ratio of the 2 lengths of the opposite and adjacent sides. So for example, here, without even knowing the angle exactly, we could determine these 3 functions easily. Remember that if you prefer to use the other notation, okay, use the notion of the trigonometric circle, which is just imagine a circle center on the origin of geometric coordinates like y and x axis. Imagine there is this circle whose radius is 1. So here is 1, here is 1, -1, and -1. So imagine that you just draw, okay? You just draw 1 radius on this circle. Say, for example, here. This is, of course, 1. If you draw the projection of this point, downwards vertically, okay, it intersects the axis x in some point. This is perpendicular, of course. So here, if you consider that this opening here is an angle that we may say that it measures x degrees, if this is x, the measure of the angle in degrees or in radians, if you will, then what is the sine? The sine is the length of this opposite side, the perpendicular leg. This is the sine of x, and this part here, the length of the adjacent side will be the cosine of x. Okay, so that's it. The sine, the cosine, and the radius form a right triangle where the measure of this angle is x degrees or x radians, if you will. It depends on the units they give you. So that's why you can always draw this in order to remember. If the hypotenuse of the triangle is 1, then the opposite leg or the opposite side to the angle is the sine, the adjacent is the cosine, and the what we call the slope, right? Remember, rise over run, that is exactly the tangent of the angle. Yeah, actually the slope, the concept of the slope in a straight line is actually the tangent of the corresponding angle, the angle of elevation of a straight line. So what else do we need to remember? Basically, if you know some well-known values or common values of sine and cosine of angles that are between 0 and 90 degrees, then you can calculate the trigonometric functions of any angle. For example, and this is also, there is a correspondence between sine and cosine, right? The sine of x is the same as the cosine of 90 degrees, that is the complementary angle, and vice versa, the cosine of any angle is the sine of the difference between 90 and the angle. So you may say that because of this, for example, the sine of 30 degrees is the same as the cosine of 60 degrees because both angles add up to 90 degrees, right? And for example, the sine or the cosine of 15 degrees would be the same as the sine of 90 minus 15, that is to say 75 degrees, and so on. Now, if they give you the measures in radians, it would be like this. This is the equivalent in radians for the 90-degree angle, a right angle, P half or P over 2. Here the same. Okay, so another important thing in order to calculate the sine or cosine or tangent is to first determine the sine, but not this sine, but this. The sine of the output of this function. It will be positive or negative. So here there is like a key to remember, right? The sine function, as we just mentioned here, you know, in this chart, if the sine is like the vertical coordinate of this point here, sine of x and the cosine of x are the, actually here is like the other way around, cosine first and sine is the vertical. So if the sine is the vertical coordinate of a point on the border of a circle of radius 1, then clear you can see that the angle will go from 0 to 90 degrees, and so the value of the sine will vary from 0 to 1, right? From 0 to 1. So that's how the value of the sine varies, you know, in this quadrant. What happens if the angle goes like this? For example, this way. So if this is the angle, still the vertical and the horizontal position are sine and cosine respectively. So here, the sine would still continue to be positive, but the cosine would be negative because it would be to the left of the vertical axis. So this can be translated like this, right? In the second quadrant, only the sine function is positive, as you saw, because imagine that you have the circle here with radius 1. No matter if the point is here or the point is here, that is to say, an angle in this quadrant or an angle in this quadrant, in the second, the vertical position of those points on the border of the circle will always be positive. So in the second quadrant, the sine is positive. The other functions, the cosine and the tangent, are actually negative. And what about the tangent? The tangent is positive in the third quadrant, okay? The tangent is positive here and is positive in the first quadrant as well. So the other functions like the sine and cosine are actually negative in the third quadrant. Yes, if it is an angle like this, perhaps, imagine something like this. Of course, here, the tangent of such angle, because as the tangent is defined, if this is the sine and this is the cosine, what is the tangent? Just draw this, prolong the radius, and this here is the tangent of x. All right. So it's exactly what you need to do. You need to prolong this radius. It would be prolonged in this direction. So you would also have a positive value for the tangent. And what about the cosine? In the fourth quadrant, the cosine is always positive, you know, in the first quadrant and in the fourth quadrant. Why? Because when you have the cosine, imagine you have this angle here, alpha, and you have another angle beta, like this. So what about the horizontal position of these 2 points? In both cases, it's positive, it's this. So that's why the cosine, the length of this, considering that the radius is 1, the length of this segment would be the cosine of those angles. So it's positive in the fourth quadrant. In the second quadrant, only the sine is positive. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. When we say only, that means that in all the other functions are the opposite. So here, only sine is positive. That means that cosine and tangents are negative in the second quadrant. Okay, in the first quadrant, everything is positive, no problem. So both sine, cosine, and tangent are positive. If the angle ends in the third quadrant, then the tangent is positive, but the cosine and the sine are both negative. And in the fourth quadrant, the cosine is positive, but the sine and the tangent are negative. So how can you remember this? Here there is an interesting idea. This phrase, you know, all students take calculus. Yeah, it's not such a good phrase, but you know, it has an acronym, ASTC. So imagine that this ASTC, there are 4 letters. This is the first quadrant, this is the second, the third, and the fourth. So what does A stand for? All functions are positive in the first quadrant. In the second, only the sine, S for sine, is positive. In the third, only the tangent is positive. In the fourth quadrant, only the cosine is positive. Okay, so that's one way to remember. If you can actually determine with some accuracy the sign of the trigonometric function, that is the output of the function, then you're good to go. The rest is peanuts. What is left in order to calculate the value of a trigonometric function after you have already determined the sign? If you have already determined the sign successfully using perhaps this mnemonic rule or any other you know, you can do this. Okay? So once you determine the sign of the result, you're good to go. Now, what next? You need to add or subtract multiples of 90 degrees from the angle they give you, or perhaps if they give you in radians, you can subtract, you know, as many multiples of p over 2 as possible until you reduce the angle. Let's say this angle is x degrees. You need to reduce the angle to be between 0 and 90 degrees, or between pi over 2 radians and 0 radians. Okay? That's a strategy. Then what else? Once you are left with a reduced angle, then you can follow the rule in step 3. You can use whatever special triangles you may know about in order to determine the exact values of the functions. So there is here the good news. In the SAT, they will not ask you to calculate trigonometric values for angles that are beyond the common triangles that we've already studied, okay? Or if they really ask you to calculate, for example, the sine of 11 degrees, something like this, if they ask you to calculate this, for sure, they will allow you to use the calculator. Actually, you know that in the new digital SAT, you are allowed to use the embedded or built-in calculator in the application, the Blue Book, right? This is the application you will use to take the exam. Okay, so now let's see the last step. Make sure your result has the correct sign from step 1. So just put together the two, the value of the function and the sign that you predicted in step 1, and there you go. Let's see several examples on how to proceed here, okay? Let me show you here a few examples. What is the value of the sine of 330 degrees? Okay, so first of all, let's determine if we drew this angle. You know, here is 90 degrees, up to this point is 180, 90 more, and up to this point is 270. So it should be something like this. Actually, this angle should be something like this. 330 degrees. It's in the fourth quadrant. So what was our rule? All students take calculus. So what does this mean? That in the second quadrant, or sorry, in the fourth quadrant, that is this, only the cosine is positive. That is to say, the sign here will be negative. We've already determined, okay, the sign of the sine will be negative. And that's it. We already know the sign of the output. Now, how do we actually calculate this? Okay, what is 330? As we see here, to 330, we can take away 90 degrees multiplied 3 times, because we can cancel this, and cancel this. What are we left with? the sine of 330 degrees, it will become the sine of 330, take away 270, which is a multiple of 90, right? And this will yield what? Well, this will yield simply 60. So that is to say, all I have to do now is to calculate the sine of 60 degrees and then place this sine here. And what is the sine of 60 degrees? Okay, here you make a use of the special triangle, the one with 30, 60, and 90 degrees. This is 30. This is, okay, you can draw it like this, although it's a little deformed. So this is 60, this is 30. So if this is 60 and this is 30, so let's say that here it's this shorter leg is 1. Okay. Let's draw it like more accurately to avoid confusions at the time you are revising for, you know, the lesson. Okay, so we have this. So here, if this is a 60-degree angle, this is 30-degree. So if this is 1, according to the principles of this triangle and the proportion of the sides, the short leg, that is the opposite side to the angle of 30 degrees, should be 1/2. And what about the side opposite to 60 degrees? This should be 1/2 multiplied by the square root of 3. So there you go, actually, right? You may say, okay, what is the sine of 60? Is the opposite side to the angle of 60 degrees divided by the hypotenuse, right? The opposite over the hypotenuse. So this would be what? Yeah, it's easy if you've already, how to say, memorized this. And actually you should, right? Most schools actually demand that their students memorize the sine of 60, 30, etc. But the thing is, you don't actually need to remember these values. You can calculate them all using the properties of common triangles. Of course, it would take a little longer, yes. So that's why it's very valuable to memorize some key values here. Okay, so the sine of 60, right, would be the square root of 3 over 2 divided by 1. So this is just this. So our answer choice would be this value with a negative sign. Okay? That's it. So let's see another example. You can try this one first, okay? Then we'll see the answer. Try it on your own. So if we determine here the cosine of 135, let's first imagine, right, in which quadrant the radius that forms this angle with the positive horizontal axis is placed. So it should be like this probably. This is an angle of 135 degrees. So this is in which quadrant? Of course, it's the second quadrant, right? So because of this here is the cosine, and this here is the sine. So you see the sine is positive, but the cosine is negative. If you don't remember that, okay, you can use the key, the mnemonic key. The S stands for sine. And since it's the second letter, that means that in the second quadrant, only the sine is positive. That means that the cosine is negative. So now we have that this is a negative value for this cosine, It's actually this here. So you see that this is negative on the x-axis. And what else? Okay, let's reduce this by subtracting multiples of 90. So the cosine of 135 will change to the cosine of 135, take away 90 degrees. And we are left with the cosine of 45 degrees. But this one's easy, right? Yes, this one's easy. If you've learned it by heart, this is the square root of 2 over 2. Where does this value come from? You can build the value, from the special triangle, the isosceles right triangle. Here, 45 degrees, also 45 degrees. So what is the cosine of this angle here? Okay, it's the value of the adjacent. Let's say if this is, for example, right? If this is, for example, let's say it's 1. So what is the hypotenuse of this? 1 over square root of 2. So what would be the definition of the cosine? The cosine would be the adjacent side divided by the hypotenuse. So this is 1 over the square root of 2. You rationalize and get square root of 2 over 2. But this is not the answer. We've just calculated the value, the absolute value of the cosine, but what about the sine? The sine, we know it will be negative because the angle is in the second quadrant. So the correct answer choice would be negative square root of 2 over 2. And that's it. So that's how you can calculate the sine and the cosine and also the tangent, of course. Let's see one more example. What's the value of the tangent of 210 degrees? Same idea. First, let's determine in which quadrant is this placed. The end of the angle, the radius forming the angle with a positive horizontal axis, where does it end? In the first, second, third, or fourth quadrant? Not sure? Try to visualize what happens in a circle. So you must draw a radius that forms an angle of 210 degrees with this part of the horizontal axis. Where should it be? Here you have 90 degrees, here you have 180, and here you have 270. So it must be somewhere in between this and this. So probably like here. This would be an angle of 210 degrees. More than 180, less than 270, right? Okay, so now that we know which quadrant it ends, the angle, so what is the sine? What about the tangent? Remember again the acronym. This is the third position. That means the third quadrant. Only the tangent is positive in the third quadrant. Since we are required to find the tangent, okay, so it will be a positive value. No problem. Now, as for the actual value of the trigonometric function, then you can see this. Say that the tangent of 210 degrees is the same as calculating at least, when I say the same, I'm referring to the absolute value of 210, take away, what is the greatest multiple of 90 that we can take away?
80?
80? 180. Yeah, very good. So we do this and we get 30. So it's just a matter of now calculating the tangent of 30 degrees. So let's draw our special triangle here. 30, 60, and 90. So let's assume any possible values, no problem. Let's say that if this is 1, this will be 2, and this will be square root of 3. So what will be the tangent? This opposite side, no? The tangent is defined as the opposite side divided by the adjacent side. So divide 1 over the square root of 3, and this yields square root of 3 over 3. So since it's already positive, this will be the answer to the question. So in that way, you can always calculate the functions of these angles. You will seldom see the request to calculate, for example, the secant or the cosecant. Yeah, it's kind of difficult. You will not see these kind of questions in the SAT. Only the sine, cosine, and tangent. So let's move on. There are special values of angles, both in degrees and in radians, that you should be familiar with. For example, what's the sine of 0? Will be 0, while the sine of 90 is 1, right? The cosine of 0 is 1, while the cosine of 90 is 0. The tangent of 0 degrees equals 0. Remember, the slope of a totally horizontal line is always 0. Remember, this tangent here is the slope of the line, or the slope of the radius, if you will, right? And what about the tangent for a 90-degree angle? It doesn't exist. It would be infinite. You know, from this here, how is the tangent defined? If this is 1, the length of the radius, and so imagine that you have this. This will be the angle alpha, for example, and this will be the sine of alpha, while this segment here will be the cosine of alpha. And what is the tangent? You draw a tangent perpendicular line or segment to the circle in that position, in this point, and then prolong the radius. Okay, this value here will be the tangent, right? So what's going on? Well, the greater the angle, with this value of alpha, which is about like 60 degrees, look how big the tangent is. If you make this angle to open up wider upwards, look that the prolongation of this will intersect this tangent line very up, very high in the positive direction vertically. So the closer that this angle gets to 90 degrees, the value of the tangent, grows endlessly. So actually, when the angle is exactly 90 degrees, you could say that the tangent is infinite, right? So it's not defined. Okay, same here, but expressing the values of angles in radians. Remember, 90 degrees is always pi over 2. Okay, so let's see a few more real examples, okay, in the SAT. We have this question. In a right triangle, one angle measures x degrees such that the tangent of x degrees equals 0.75. What's the value of the cosine of x? Okay, can you try? Please, go ahead. Try to solve this one. Use what you already know about special triangles in order to help you build the tangent, okay? Remember that the tangent of an angle of a right triangle is always the quotient or the ratio of the length of the opposite side to the angle divided by the length of the adjacent side. So you can use this as a starting point. Okay, good try, Madeleine. Very good. Let's see, people, how we could do this. First of all, notice this. The tangent of x is 0.75. We should try to work with fractions here because it will be easy to visualize. What is 0.75? 75 over 100, which is indeed 3 over 4, right? So imagine this as per the definition of tangent. This is the length of the opposite side divided by the length of the adjacent side of one angle inside a right triangle. So if we are saying that this is the tangent of x, it's because we can visualize one right triangle that exactly possesses one angle x, and the opposite side to this angle is 3, the adjacent equals 4. But you know, if a right triangle has two legs that are 3 and 4 respectively, then you can see clearly that the hypotenuse must be 5. This is one of the special triangles, right? Also, you can calculate this using the Pythagorean theorem, no problem. So now that we have the triangle complete, we can easily visualize here how to calculate the cosine. The cosine would be actually the adjacent side divided by the hypotenuse. So what is the adjacent side? 4. What is the hypotenuse? 5. So this would be 0.8. Although in the SAT, you could also input this value as a fraction. Both are valid, okay? Both are valid, as long as you indicate clearly that it is a fraction. Okay, so that's it. Any doubts here? Any uncertainties? No? Okay, so let's try another example. Take a look at this one. Okay, people, let's see. What did we say about the tangent? We can visualize the tangent, right, of an angle, imagining that we have a right triangle where one of the angles is exactly this, x, and in this triangle, the calculation of the tangent is the ratio of two lengths, the opposite side divided by the adjacent side. That's the tangent, right? So think about this for a moment. If this is the tangent, that means that if we compare this or equate this to m, okay, we could say that this is the same as m over 1, right? So if this triangle had a side opposite to angle x of m units and an adjacent side to angle x of 1 unit, then the calculation of the tangent would be accurate, m over 1, that is m. But if these are the two legs of this right triangle, then what would be the hypotenuse? And why do we need to calculate the hypotenuse? Because we are being asked to calculate the sine of x, and the sine is defined as the quotient of the opposite side divided by the hypotenuse. So let's first calculate the hypotenuse in terms of 1 and m. In our triangle here, if we apply the Pythagorean theorem, what would be this that we can call the hypotenuse? According to the Pythagorean theorem, would be that 1 square plus m square should be the same as h square. Therefore, the value of h would be the positive square root of 1 plus m square. Or m squared plus 1 is the same. So now that we have the hypotenuse in terms of m, we can actually calculate what the sine of x would be. Using the values of this same triangle, then the sine would be the ratio of the opposite side divided by the hypotenuse. What is the opposite side? Okay, m. What is the hypotenuse? The square root of 1 plus m squared. Which one matches our result? Take a look. Not 1 or not A, not B. This one, m over the same root we just found. C is the correct answer choice. Okay, that's it. Let's see one more example of trigonometry questions in the SAT. Okay, here. It says the cosine of 32, I understand is 32 degrees, right? Equals the sine of 5n minus 12. If in the equation above, the angle measures are in degrees, of course. If 0 or if m is between 0 and 90 degrees, what's the value of m? Now be careful here, okay? We all know that both the sine function, okay? The sine function is always between, 0, it can take the value of 0, and it can take the value of 1, but it could also be -1. So it's actually between 1 and -1. And so is the cosine. The cosine of an angle could also be between 1, +1, and -1. That is to say that the sine and cosine always take decimal values, either positive or negative. They can be 0, they can be also 1 or a -1. Okay, here I should include this. If you remember this basic fact about these two trigonometric functions, you will never, make this mistake. For example, here, some people say, oh, okay, they are telling me that the cosine of 32 equals the sine of this, take away 12. But this would be impossible. How come that if you reformulate this like this, that the sine of 5m minus the cosine of 32 would equal 12? It's impossible that the difference of two trigonometric functions, sine and cosine, no matter what the angle is, will yield positive 12. This simply cannot be, okay? So be careful, don't interpret this as just like the sign only apply to 5m. It applies to everything, okay? It should be like this. Rather, all of this is the angle. Okay, having said that, please try to continue and get to the answer on your own first. Okay, let's see the answer to this question. So, since it was impossible, to consider that the sine only affected to the angle 5m, it would make no sense to have a difference of a sine and cosine of 12. Then we consider that the whole expression is the value of the angle. So we know from this identity that the cosine of 32 must be the sine of 90, take away 32. In other words, the sine of 58 degrees. Since the cosine of 32 equals this, we can match the two expressions and say that the sine of 58 degrees equals the sine of 5 times m minus 12. It is true that the sine of two angles may coincide, not necessarily if the angles are the same. Yeah, you can also have this, right? For example, the sine of alpha is always equal to the sine of alpha plus 2 times, or if you want with degrees, 360 times n, where n is a positive integer or a negative integer, no problem. Yeah, if you know, for example, have this angle here, this is alpha, this would be exactly the same as giving a whole round and then get here. Exactly the same. It will have the same sign. So, but since we are considering a possible value of m that is between 0 and 90, let's first try to equate directly these two values. Let's assume that n is just 0 here. So it's just the two angles match. So if 5m minus 12 equals 58, this would mean that 5m would be 58 plus 12. And this is it, set 70, right? So from this, m equals 14. Since the angle we found fits the interval given, then there is our answer already. Okay? Well, these are the kind and level of questions that you can expect in the SAT about trigonometry, so no problem, right? Let's now talk about another type of questions that is called reading data questions. These questions are focused on interpreting correctly some charts or diagrams that contain numbers or figures or values or data in general. So we'll see a few examples. There is not like a specific technique to tackle these questions. You can just trust your knowledge of arithmetic algebra in order to, get these questions right. Let's see a few examples. Take a look. Say, for example, this question, what do we see? First, we see a kind of chart, right? A diagram. It says commute times, and then it gives us on the vertical axis, the commute time from work, and the horizontal axis is the commute time to work. Okay, then we need to check what the stem says for 4 work days. Alex, is Alex present? Oh, yes, he's. Alex plotted the commute time to work and the commute time from work in the grid above. For which of the 4 days was the total commute time to and from work the greatest? So, how are we supposed to do this? Think about this. For example, in the first day plotted by Alex, which we can think is A, right? This is the first one. What would be, according to the grid, the corresponding or approximate commute times to and from work? Okay, let's try to be like very visual here. This would be approximately the commute time to work. You see, it's like 2/3 of the way or the space between 15 and 30, like 2/3, right? So if we say that we divide this in 3 parts, we can say that each of these is actually 5. So more or less, this value would be approximately like 20 minutes, right? 20 minutes, yes. What would be the commute time from work? Well, this sits exactly on the position corresponding to 60 minutes. So the total commute time for A would be approximately 20 plus 60, that equals 80. So you got it, right? That's how the total commute time can be calculated for each of the days. Now the question is, which would have the greatest value for total commute time? For TCT, right? What would be the greatest TCT value for which of the days, A, B, C, or D? What say you? C, right? Yes. Yeah, you can continue the estimations. You have, you can just answer either of the four. Yeah. So what about the total commute time for B? Approximately here, somewhere between 30 and 45. So let's say 38 approximately. And here, somewhere like 2/3 of 45. So this is like 40 perhaps, more or less. So this is like about 78, quite close. So we need to check the other two. The total commute time for C is 45, the time to work. And for time from work, it's about here. So it's like 1/3. So here is like 80, more or less. So this is 125. Definitely we can, cross out these two options because neither of them is even close to this value. And finally, discard the last one by checking here. This is about, let's say, 80. And this is about, let's say, like a third of 15. So 15 plus 5, 20. Okay, so it would be like 80 plus 20, 100. This is still the greatest, so the correct choice would be C. So it's about that. You need to read carefully the information in the chart, and that's it. Let's try some other examples. Okay, I'll leave it up to you to study the question and then volunteer an answer, okay? Let's see what you can do. Okay, people, you got it. Actually, what we're looking for here, right, is this difference. We're comparing this difference between the two curves. For example, this point and this point. The length of this segment signals the difference of the voters' turnouts. So as you can see, if we draw the segments connecting the two graphs in all years, you can see clearly that here is where the difference of turnouts is the least possible. So it must be option C. Okay, let's try one more question. Try this one. Okay, here again, the chart shows a line graph with the ice cream sales in, in a period of 2 years. So, okay, in which 3-month period were the sales highest? Okay, in the 2 years at the same time, this is the period where the sales is highest. So this corresponds, if we, plot this, July, September, and so is here. July, September. Okay, so option C. Very good. Okay, people, now let's move on to, I think we have, okay, one more example for this. Try this one. Okay, so here we can see clearly that since we're trying to interpret a general trend from these, charts, these line graphs, clearly is a descending trend, right? So you can see that we can immediately cross out these two options that show increase. And between, the first and the second, here it says increase in Japan. So no, it has to be decrease in both. A. Okay, let's now talk about probability. So probability questions are many different types and complexity, but in the SAT, what they actually require is to have a basic understanding of a definition that is based on statistics. Okay, when you talk about probability, you're talking about a ratio, that's a number, a figure, that measures the likelihood or how possible it is that a certain event, turns out in one or more expected ways. Say, for example, if you throw a die, the little cube that people use to gamble, the little cube with dots, different, numbers of dots on each face from 1 through to 6, right? That's a die. It's not a verb. This is a noun, people. And the plural of die is dice, okay, in plural. So when you throw a die, this little cube, you know that this event, throwing a die, can turn out in any of 6 possible manners. So the total number of manners in which an event can happen, this is what we call the number of total possible outcomes for the event. Now, particularly, what if we want to determine what is the probability that when we throw a die, the number showing up is actually an even number? So we need to calculate what is the number of target outcomes. In this particular case, it would be the number of even results divided by the total number of outcomes when you throw a die. Okay, this part here is easy. We have just calculated this. According to the definition or the concept of throwing a die, it's just 6, the total outcomes. But if I want to determine the probability of obtaining an even number when you throw a die, then how many even results do you have on the faces of a die? You have this, right? You have 2, you have 4, or you have 6. These are the only even values. So how many of them? There are actually 3. So the probability would be 3/6 or 1/2, or if you want 0.5, or sometimes they can express it as a percent. Yes. So that's a probability in general. Now, what would be the probability of throwing a die, one die, and obtaining 5 on the upper face? What would be that probability if you apply the definition? Anyone? Okay, good. 1/6. Very good. Yeah, because 6 possible outcomes, the 6 faces of the die, but there is just one face of the die that shows number 5, right? So 1/6. And so on. Now, when in the SAT, you see probability questions, these are connected to tables of data. So for the SAT, a probability can be defined like this, right? A ratio of the number in the target group divided by the number of elements in the group under consideration, that is the total elements, okay? The target group refers only to a specific subset of the original group. Let's see examples of this, all right? Here, we see first a table. In the table, there are 2 entries. Actually, here vertically, you have beef and chicken. And in the rows, you have first class and coach. That is 2 types of, flight tickets. right? And beef and chicken is the two types of food they serve. So the table above summarizes the meat preferences of passengers on a particular flight. If a first-class passenger is chosen at random from this flight, what's the probability that the passenger chosen prefers beef? Okay, think about it. This, you need to be very careful. When you want to know where to look for information in the description that helps you put together the fraction that is defined as the probability, remember this. This, what is the probability phrase, is like a pivot phrase. Whatever comes after that phrase always refers to the numerator of your fraction. That is to say, refers to the number in the target group. While whatever comes just prior to the phrase, what is the probability, then refers to the total group under consideration. So, what is the probability the passenger chosen prefers beef? And what is actually prior to the phrase? First class passenger is chosen at random. Okay, so what is our group under consideration? Is the first class passengers. Not all the passengers, only the first class passengers. So, what is the total number? This is the number of first class passengers. And what is the target group? What comes after the phrase? Passenger chosen prefers beef. Among those who are in first class, the ones who prefer beef. So first class passengers preferring beef. So now we are ready to do this calculation. This is the probability we're looking for. Okay, in the denominator, we would have to place the total number of people in first class. Okay, so 18 plus 27. And what is in the numerator? The numerator would be only those first class passengers that prefer beef. So those are 18, right? Be careful. Don't go for all the passengers that prefer beef, which would be this group. That would be incorrect because we are not choosing the passengers that prefer beef among all the passengers. Here, the premise says that a first class passenger is chosen at random. So we don't care about the passengers in coach. Okay, be careful. Okay, now, what is this? 18 over 45. Divide by 9, 2. Divide by 9, 5. Okay, the answer is 2 over 5. Option B. Okay, so that's how probabilities questions are seen in the SAT. Okay, so let's see some other example. Example 2. The manager of a large assembly line uses the table below to keep track of the number of vehicles that are produced during different shifts in the day. It's a table there. If a vehicle is selected at random at the end of the day, which of the following is closest to the probability that the vehicle will be either a car produced during the first shift or a truck produced during the third shift? Okay, you can use your calculator, of course, no problem. Try this one to see what happens. Okay, let's see, people. The question 2. This question first says that we need to calculate the probability But what is the group under consideration first? Notice that, you know, before the question, what is the probability? There is this part. If a vehicle is selected at random at the end of the day. So what is our group under consideration? It's any vehicle that has been manufactured in the assembly lines. Since at the end of the day, there are totally 3 shifts, and we have a big total of 898 vehicles manufactured at the end of the day. So this should be the base for our calculation. 898 in the denominator. Now, what is our target group? That is to say, what is those types of elements that we're actually interested in getting picked? Here it says, you know, after what is the probability phrase here in this part. After this, it says the vehicle will be either a car in the first shift or a truck in the third shift. So since they tell you either or, when they tell you this, it means an addition of 2 groups. So what is the number of cars produced during the first shift? According to the table, is 173. And the trucks produced during the third shift would be this number, 109. So what we need to calculate here is do this quotient, right? 282 divided by 898. If you do it in your calculator, what you get is this value. This is approximately 0.31403. Okay, we just keep this one. We can just actually round it to option B, the closest. Okay, so that would be it. So that is the concept, and we'll see some more examples. Here, please, try this one. Okay, what is the answer to the question here? Think about this. We have the violation records, driving violations by type and vehicle. Don't let this initial information fool you, because the question is, you know, phrased in a very particular way. You need to understand what they're really asking you. Which of the following is closest to the proportion of stop sign violations committed by truck drivers? So what does this mean? Does it mean the total number of truck drivers stop sign violations divided by the total number of driving violations? Or does it just mean the number of sign violations committed by truck drivers divided by the total number of stop sign violations? Which of the two is the correct understanding? Okay, please pay attention to this, because if you thought that it is actually the sign violations committed by truck drivers divided by 284, this is not what they're asking. It is just divide 39, that is the violations committed by truck drivers, the stop sign violations, divided by the total number of stop sign violations, which is 90. This is what they're asking you here, okay? So if you do the operation in your calculator, you get this, 0.44 433. So you can round this to option C. Whenever you see similar wording in a question, remember it is the second interpretation. They are not asking you to calculate against everything. Okay? Why? Because here, the fact that, you know, the group that is being considered is mentioned by saying the proportion of stop sign violations. These proportions refers to the stop sign violations only, not all the driving violations. And among those, you are interested in mapping the percent or the fraction of those fractions committed, in violations committed by truck drivers, okay? So this is the correct way of understanding this question. Let's try another one more example here. Okay, let's do this. The question says, based on the table, if a plumber in California is chosen at random, okay, think about it. If you choose, you know, plumber at random, that is to say, how many options do you have for choosing that plumber? Obviously, you would have to choose among all the plumbers available, which is this amount. So we know that this should be in the denominator. Our reference group is plumbers in general in California. Now, what about the target group? The target group is a little different. It says, which of the following is closest to the probability? So this is our pivot phrase. What comes after indicates the target group. The plumber has at least 4 years of experience. So we are hoping to choose plumbers that have at least 4 years of experience. What does it mean at least 4? It means 4 or more than 4. So here you can see the plumbers with 4 years of experience, while here you can see the plumbers is a different group with 5 years of experience. Okay? So because of this, the total number of at least 4 years of experience should be 40,083 plus 45,376. Okay, if you do this in your calculator, you get approximately 0.46. This would be the answer. That is to say, option D. Okay? Well, let's keep going. I think this is it. One more. Okay, it's the same table, people. Be careful. Same information, but now it's a different question based on the same table. Okay? Please try your best. Okay, let's see this last question. If a worker with at least 4 years of experience is chosen at random from those included in the table, which of the following is closest to the probability that the person is a plumber? So you see here, you know, before the pivot phrase, which is or what is the probability, this information signals the reference group, okay? So we're talking about a probability of choosing among a total group of the people with at least 4 years of experience. So we need to focus on the people with 4 years of experience or more. In other words, the total in the denominator would have to be the sum of these two. Okay? 182,410 plus 208,757. That would be our reference group. And what would be our target group? What are we expecting to obtain? You know, if we pick at random that the person is a plumber, okay, among all those people in the denominator, we expect to get a plumber. Who are plumbers among those people with more, with 4 or more years of experience? Well, here, right? This group corresponds to the plumbers with 4 or more years of experience. That is to say, at least 4 years. Okay? So the numerator should be this sum. Okay, that's it. So what do we have? If we do the math using a calculator, of course, then we get approximately this value. Okay, so it's option B. Yes. Okay, so that's good.